Hello friends, this is my presentation for the PL Hash Week 2021. Package management is good, but it could be content addressed. As we know, IPFS loves hashes. There's hashes everywhere. We want to hash the world. Package management, or should I say Hashage management, also is heavily involved in hashing. There's hashes all over the place. You might have seen hashes in your package lock file if you're using NPM. You might have seen hashes in your GoSum file if you're using Go modules. Over Christmas, I started a little project called Forest, which is an IPFS-backed package manager proxy cache. This basically works a lot like Artifactory or Sonatype Nexus, if you've seen those things before. Runs as an Electron app and has a spiffy little web UI that draws a nice random forest based on the packages that you have installed. It works by getting in the middle of your package management requests to registries, and when they successfully complete, it stores a copy of those packages on IPFS and then announces them over PubSub for other people to be able to install those packages directly from IPFS without needing to download them from the registry again. That is kind of where we were at the start of the week already. But wouldn't it be cool if we could do more stuff over IPFS and talk to the registries less if things were content addressed correctly? Possibly. If we look at different kinds of hashes that are stored in these different kinds of package managers, they're not that alike. Compared, and they're not quite the same as IPFS hashes. What we really want to get to is a point where all the hashes are CIDs, and then we can feed them into IPFS and it'll all just work. I consulted the Oracle, also known as a Dean, in some extra options that you can set for IPFS add, raw leaves, and setting the chunker to a certain size, and then matching the hashing algorithm to the one that a particular package manager uses. NPM uses SHA-2 512 and Go uses SHA-2 256. Then I wrote some code that basically was able, after using that those options, I can predict what hash will be if the package is under 1 megabyte, i.e. it fits inside a single block. Then we can compare that. If we actually do an IPFS add, you can see the hash is the same. When we hash the tarball, we get the CID, but we predicted the CID before we actually did that, before we downloaded it. This means we can read those hashes, those integrity hashes from the package lock file or from the GoSum file, and request them from IPFS without ever having to talk to the registry or download any tarballs and hash them first to be able to calculate what they should be. This means that a user with a package lock file can potentially pipe all their requests for packages directly from IPFS from other users who have already downloaded their packages, and if they can't find those users, they can always fall back to downloading those packages from the registry and then start co-hosting them for other people to be able to pull them down later themselves. Very cool. I've got this mostly working. There's a few caveats. The packages have to be smaller than 1 megabyte in size for NPM. This isn't too much of a problem because maybe 98% of packages are about less than a megabyte. There's only some large ones that contain bins and big images and things that don't work yet. We can just fetch those from the registry and then announce them over PubSub in the way that it was already working. Hashes need to be stored in lock files. Some package managers like RubyGems don't do that, so we'll have to go to the registry to fetch those things right now. And Go package management has some weird hashing that we need to do extra steps internally. Makes it slightly slower on the first pass, but it does work. And I have the code to prove it in this pull request. You can check it out. Don't judge me too harshly. It's pretty ugly right now, but it is working. And I will be working to merge this in kind of over in my spare time over the next few days. Thanks very much. Also, thanks to Ollie Zilla for his support this week, and Mabel, although she's much bigger than that when that picture was taken. Thanks very much. See you later.